Hello, let's begin section 2.4, product and quotient rules. Okay, so if you have a product, when we're multiplying these two functions together, x to the third and x to the fifth, what you have to do is you have to split them apart kind of and look at each piece separately. So what the product rule tells you is you take the derivative of the first, okay, that is f of f prime x, times the second, plus derivative of the second, which is g prime x, times the first, times f of x. Okay, so let's do this example here. So I'm going to call this function f and that function g, and you want to do f prime g plus g prime f. Okay, so f prime g, and if it helps you, you can write out the bits on the side. F prime is 3x squared, and g prime is 5x to the fourth. Now you have to put all of this together. Okay, so we say f prime g plus g prime f. F prime is 3x squared times g itself, the function g is x to the fifth, plus g prime, which is 5x to the fourth, times f, which is x to the third. Okay? And then we're going to distribute, so we get 3x to the seventh plus 5x to the seventh, and then you combine and you get 8x to the seventh. Okay? So that is our final answer. Now we can verify this example. Let's verify this example by using the laws of exponents. So I know the derivative of x to the third times x to the fifth is the derivative of x to the eighth. And we know how to take the derivative of x to the eighth. Remember, the power comes out front. We did this last time, minus 1. So that's 8x to the seventh. So you can see that these answers match. Alright, let's do some more examples. So again, I'm going to call this guy f and this guy g. So f prime is 2x plus 3, because remember I need to do f prime g plus g prime f. Okay, you do that a bunch of times and you memorize that. You can also remember derivative of the first times the second plus derivative of the second times the first. Okay, so we have f prime, and now we need g prime. G prime is the 3 comes out front, so we get 15x squared plus 4. Okay, now we combine it all together. F prime is 2x plus 3. G itself is 5x cubed plus 4x, plus g prime is 15x squared plus 4, and f itself is x squared plus 3x plus 5. Okay, then we check f prime g plus g prime f. Okay, now we can simplify this thing. Now we have to distribute, right? So I'm going to do the 2 and the 5x cubed gives me 10x to the fourth, and then 2x times 4x is 8x squared plus 15x cubed plus 12x plus. Okay, that was the first part. Now this part, 15x to the fourth plus 15 times 3 is 45, x to the third plus 15 times 5, which is, let me erase this plus right here, 15 times 5, which is 75, x squared plus, so now we have to do these guys. So 4x squared plus 4 times 3, 12x plus 20. Okay? So it's a good idea to check the terms, right? There were 2 and 3, so that's 6 terms, and 2 and, no, there's 2 and 2, so that's 4 terms, sorry. And 2 and 3, so that's 6 terms. So I should have 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then this simplifies to 10x to the 4th and 15x to the 4th. So that's 25x to the 4th. Plus 15x cubed plus 45x cubed, 60x cubed, plus 8x squared and 75x squared, and then a 4x squared. So we've done this, we've done this, we did this one, we did this one. So we have 8x squared and 75x squared, and that is 83x squared. And now we have, but we have a 4x squared too, so let me include that. So we have 8 and 4, that's 12, so 12 and 75, which is what, 87, right, so these are gone, and then the 12x and 20. Okay, so that is our final answer. Let's do this one. So let me block this off here. 2x, so f again, f prime. This is f. That's g. F prime is 2. G prime is 4x squared, 4x to the 3rd. F prime g plus g prime f. F prime, as we said, 2. X to the 4th plus 6. G prime is 4x to the 3rd. 4x to the 3rd, and then f is 2x. Okay, so this becomes 2x to the 4th plus 12 plus 8x to the 4th, which is 10x to the 4th plus 12. And this one, you can also do another way, right? It's actually easier to distribute first, so you don't have to use the product rule. So from here we can do 2x, let me just rewrite the problem. Okay, so you can also do 2x times x to the 4th is 2x to the 5th plus 12x, right? And then you want to keep that d over dx. So the d over dx means take the derivative. And then once you've taken the derivative becomes 10x to the 4th plus 12, right? We're done. We don't need to write the derivative sign again. So this is the answer. So look at this. We can use the product rule, but it's simpler to just distribute first. And you'll see problems like that. Now, if I ask you, like on a test or quiz, to use the product rule, then I want you to use the product rule. But if it says using any method or it doesn't specify, then you can use any method. And if I were doing this, I would just distribute first. Okay, it makes it simpler. Okay, let's look at this one. Root x, so let's use the f prime and g prime. Okay, so root x is like x to the 1/2. And so the derivative of that is 1/2 x to the minus 1/2, which is 1 over 2 root x. Okay. Now we need to do g prime. G prime is the derivative of 2x minus 4, which is 2. Okay. Again, I'm calling this part f and this part g. Now we need to do f prime g plus g prime f. f prime is 1 over 2 root x, and g is just 2, so that's multiplied by 2 gives me this, plus g prime, oh I'm sorry, see, let me erase this. F prime is 1 over 2 root x, and g prime is this here. F prime is this, and sorry, f prime g, so we're looking at g. G is 2x minus 4. Oh, it's been a long day. Alright, so there we go, and then plus g prime, which is 2, and times f, which is root x. Okay? And we don't need that parentheses there. So g prime f. Okay? And then you can write this simpler as 2x minus 4 over 2 root x plus 2 root x. And then if you wanted to, now this is an acceptable answer, okay? But I see that I can factor a 2 out of everything. Out of 2 root x plus 2 root x. So the 2 on the top cancels out with the 2 on the bottom, and we get x minus 2 over root x plus 2 root x. Okay? So this is fine, and this is completely simplified, right? This is simplest form. Okay. Let's look at the quotient rule. Now the quotient rule is the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared, okay? So that's f prime g minus g prime f all over g squared. Okay, so if you look before at the product rule told us f prime g plus g prime f. And the quotient rule tells us this. So if you look at the product rule, you get f prime g plus g prime f. The quotient is f prime g minus g prime f, and then the bottom squared. You can also remember low d high minus high d low over low squared. So that's low, which is the bottom, d high, derivative of the top, minus high, which is the top, d low, derivative of the bottom, over low squared or low low. However you want to remember it is fine. Let's look at this problem here. So f is going to be x to the 9th, g will be x to the 3rd, f prime is 9x to the 8th, g prime is 3x squared, and then we have f prime of g plus g prime of f, which is equal to 9x, I'm sorry, ooh. F prime g minus g prime f over g squared, which is equal to f prime is 9x to the 8th, g is x to the 3rd, minus g prime, which is 3x squared, times x to the 9th. That's f. All over g squared. G itself is x cubed squared. Okay? And then we can simplify this as 9x to the 11th minus 3x to the 11th all over x to the 6th. So we get 6x to the 11th over x to the 6th, which is 6x to the 5th. Okay? And to verify this using the laws of exponents, we have x to the 9th, d over dx, x to the 9th over x cubed. That's d over dx. Because I haven't taken the derivative yet, I'm just writing it as x to the 6th. Right? I'm just changing it. Now I'm going to take the derivative, so I'm writing d over dx. That's 6x to the 5th. And that matches there. Okay, so let's call this guy f, and this guy g. F prime is 2x. G prime is 1. So now we want to do f prime g minus g prime f over g squared. F prime is 2x. G is x plus 1 minus g prime is 1. F is x squared all over g squared. So that is x plus 1 quantity squared. And now we want to distribute this guy. So 2x squared plus 2x minus x squared over x plus 1 squared. And the 2x and x squared go away, so you get x squared plus 2x over x plus 1 squared. Okay? And then this is perfectly fine. If you're like doing problems in the book and you're checking your answer in the back, they might pull out an x. Okay? And that's also acceptable. So both of these answers are perfectly fine. Okay? Let's look at this one. This is f, that's g. F prime is 4x. G prime is 2x. So now let's do f prime g minus g prime f over g squared. And that is f prime is 4x. G is x squared plus 1 minus g prime, which is 2x, times f, which is 2x squared, all over g squared, which is x squared plus 1 squared. Okay? And you multiply that out, and you get 4x cubed plus 4x minus 4x cubed. So I distributed the 4x here, and then minus 2 times 2 is 4x cubed over x squared plus 1. You don't have to FOIL out that. Just leave it as it is, because the top, these two will cancel out anyway. So I get 4x over x squared plus 1 squared. And this is my final answer. Okay? And now let's do this one. F, G, F prime is 0. The derivative of a constant is 0. G prime is 2x. So now when I do f prime g minus g prime f over g squared, f prime is 0, g is x squared, minus g prime is 2x, f is 5 over g squared, which is x squared squared, which is x to the 4th. We can simplify this, right? This goes away, and I'm left with minus 10x over x to the 4th, which is minus 10 over x to the 3rd. And that's our final answer. There's another way of doing this. If you look at d over dx of 5 over x squared, you can write this as d over dx of 5x to the negative 2, right? So then you can avoid having to do the quotient rule, just like the examples we did above with the product rule. This becomes a not a quotient. So then we can do what we did before, bring the 2 out front. You get negative 10x to the minus 3. Okay? Remember, it's this guy out front and then minus 1. Okay? And that becomes negative 10 over x cubed. So again, if the problem or the instructions don't specify what method to use, then use whatever simplest method you can. If it says use the quotient rule or use the product rule, then make sure you use that rule. Okay. Scroll down. Let's review example 6 in your book on page 128. Okay. So right here, finding the cost of cleaner water. Practically every city must purify its drinking water and treat its wastewater. The cost rises steeply for higher degrees of purity. If the cost of purifying a gallon of water to purity of X% is this, 2 over 100 minus X, find the rate of change when the purity is 90%. Okay? So the rate of change, we know the rate of change is the derivative of the cost function. So remember slope of the tangent line, rate of change, the instantaneous rate of change. So here they're going to do the quotient rule. Okay, so 100 minus X, that's G. So they did G prime. Oh, and I cannot write on this part, but I can illustrate for you that G prime and times the this is G, sorry, 100 minus X is G, and that is, the 0 is the derivative of 2 minus the derivative of the bottom, which is minus 1, times the top, which is F. Okay, so they have F prime G, they just written it backwards, so we do F prime G minus G prime F, okay, divided by G squared. And then you can go ahead and simplify, and this simplifies to 2 over 100 minus X squared, okay? 100 minus X quantity squared. And it says find the rate of change when the purity is 90%. Okay? And sometimes you're like, how do I know if I keep it a percent or a decimal? Well, look at the problem. It says if the cost of purifying a gallon of water to a purity of X%. So you have to know that X is in terms of percent. So we're going to keep this as 90. Okay? So what you can do is plug 90 into what you got for the derivative, and you get 0.02. Okay? So that means at 90% purity, the rate of change of the cost is 2 cents a dollar. Okay. Now remember, we talked about marginals, so that is marginal cost 2 cents more. Okay, for each additional percentage of purity. When you have 98%, though, it goes up a lot, doesn't it? It goes up to 50 cents. So at 98% purity, it's going to cost 50 cents more for each additional percentage of purity, which makes sense, right? Extra percentage of purity is of 98% is 25 as costly as the 90%. For pure water, we have to pay for it. Alright, let's look at average cost. Okay, so when you think about average, what you're doing is adding up, this is regular, you add up a bunch of numbers, right? And then you divide by how many you have, right? So add up by however many numbers you have. So what average cost is basically the cost function divided by total number of units, which is going to be X. And then there's the marginal average cost, which is the derivative of the cost function. Marginal average revenue is the derivative of the average revenue function. And then marginal average profit is the derivative of the average profit function. So anytime you think of the word, see the word average, you want to think of dividing by X. And anytime you think of the word marginal, you see the word marginal, you're going to take the derivative. So when you see marginal average, I'll abbreviate marginal average, that means you're going to divide by X first, and then you're going to take the derivative of that whole function. Okay? Let's do an example. So printing on demand, right? That's a big thing now. If you want to print and rewrite a book or anything, you can just print it on demand. It makes it feasible to print small quantities of books, even a single copy, thereby eliminating overstock and storage costs. For example, POD, printing on demand publishing a typical 200-page book, would cost $18 per copy with fixed cost of $1,500. Therefore, this is the cost function. We want to find the average cost function. So ACX, okay? So let's use the notation that your book uses. That's Okay, that is the cost function divided by x. Now the cost function is 1800 or 18x plus 1500. Let me write that here. Over x. Okay. And now we can, so that's part A, find the average cost function. Oops. Okay. Part B is find the marginal average cost function, which is the derivative of the cost function, which is this guy up here. Okay, or the derivative of the average cost function, which is this guy up here, because it says marginal average. So that's the derivative of 18x plus 1500. Okay, so it's good to write out these steps in between. You know, that's part of showing your work. So now we have to do the same thing we did before, f prime and g prime. F prime is 18, right? And g prime is 1. So derivative top and derivative bottom. Now we're going to do f prime g minus g prime f, which becomes 18 times g, which is just x. G prime is, whoops, hold on, sorry. F prime g minus g prime of x over g squared. So that is 18, and g prime, or g, sorry, is here x, minus g prime, which is 1, f is 18x plus 1500 all over g squared. Okay? And if it helps for you to write out, you can write out the function, and then you can write out g. So then you can just look at these and do this problem. Okay? So we did f prime g minus g prime f all over g squared. Now this becomes 18x minus 18x minus 1500. Remember, we have to distribute the negative over x squared, and it becomes minus 1500 over x squared. That's the marginal average cost function. Okay, so that is part B. And it says find the marginal average cost at x equals 100 and interpret your answer. Okay, so at x equals 100, what they want us to do is find the marginal average cost of 100. Okay, so instead of x before in part B, I'm going to plug in 100 squared. So that's minus 1500 divided by, so 100 has 2 zeros, so when you square that you get 4 zeros. And then 2 of these zeros cancel out with 2 of these zeros, which is minus 15 over 100, which is minus 0.15. Okay, so that is part C. So it says find the marginal average cost at x equals 100 and interpret your answer. So that means it costs 15 cents less. Oops. The average cost is 15 cents less after 100 books have printed or have been printed. Okay. Now, if a function is differentiable at x, then it is continuous at x. So this is where, look at the examples we've done. Where are the functions discontinuous? For which x values? So let's look at this example right here, this printing on demand example. Here, x cannot be negative, or x cannot be 0. Sorry, right? X cannot here, so x cannot equal 0. When you divide by 0, that doesn't work. Can x be negative? So can x be negative? Yes. Or mathematically it can be. But not practically. You cannot print, but not practically. You cannot print negative books, right? So just be cognizant of that. This only works for positive x values. And all of these functions that we looked at, especially the quotient rule, okay? When you plug in certain values, that function will not exist if the denominator is 0, okay? So that is 2.4. If you have any questions, please come see me. I have office hours posted on the syllabus, and I can also meet outside of those hours, and I can also meet you online, okay? So thank you for watching.